All right, so I presented this machine learning stuff at DEF CON, last couple of DEF CONs actually, and so I had an introductory presentation for it, which I think is worth going through because there's quite a lot people don't understand about these about machine learning things. So I got general information here, but this is something I brought up earlier. I was really pleased to find this. You know, Gartner is in the business of predicting the future, seriously, and let me zoom into this. But first, I'll say this is the hype cycle. I imagine you know, if you're not, this is the way it always is. You have expectations against time. And so first something is new and nobody knows what it is. Then there's this giant rush, the peak of inflated expectations, and people say, this is the new thing. It's going to solve all our problems. It's going to change the world. We'll all be rich. Then there's the trough of disillusion when they begin to realize whatever the new thing is, gee, it's too expensive. It doesn't work that well. It's not doing all the stuff we promised. Everyone hates it. Then after they're done with all the nonsense, you end up in the middle. It's just another thing like spreadsheets and cars and all the other things. It's got some virtues, but it's got some faults. And this is the plateau of productivity. When you're done with all the nonsense and you just add it to your stack of tools like everything else. And if you look at this thing in detail, this is the artificial intelligence one. So it's pretty interesting to see where things are. And so here we have autonomic systems and causal AI and such, then various kinds of AI here. And notice generative AI right at the peak, which I really think is fair. This is the large language models that we've been hearing so much about. And the current models cost about, I think, $1 billion to train. You take like 10,000 GPUs and a huge amount of processing time, and then you have a model you can run on any system, like even a cell phone, after you've trained it. But you have ChatGPT and Claude and everything, and I think everybody's been integrating this into their workflow at every workplace. And people, in the last 3, 4 months, I've been seeing a lot of articles about how the bean counters are coming in and saying, wait, how much money did we spend on this? And how much real value did we get out of it? Is it really helping? And most surveys of people at work say, no, it's just in the way. It's just another confusing thing. I can't figure out how to use it. Um, and so that's why I think we're at the peak of inflated expectations. And people are still throwing money at it. And the developers here in Silicon Valley will tell you, oh, it's the greatest thing. It's going to get 1,000 times better. People will cheerfully spend $10 billion to trade the next one and $100 billion to trade the better one after that. And I'm thinking, I don't think all that money is really forthcoming anymore because the benefits are not really that great. And so anyway, I think that's a fair statement. And the thing that I mentioned before that I really like is AGI right here, artificial general intelligence. And the triangle means they see no possibility of anything actually being valuable here in the next 10 years, which is as far as they go. People think this is awesome. They think it's about to happen, and it doesn't even exist. And there's no actual prospect of it existing ever. But people pretend it's going to be awesome. And then you got like computer vision, I think is the one that's actually through all the nonsense and now actually useful. And autonomous vehicles are down here currently in really disgrace. They just grounded GM's whole fleet. It's just sitting in a parking lot in San Francisco. I've been some big flops, but I think Waze there's one of them is actually got a running taxi that people are using, Waymo. So I think it's about to reach the plateau of productivity. But right now we've finished the peak and we've finished the trough, and it's just beginning to sort of realize these autonomous vehicles are going to be there, but they aren't going to be so great that we fire everybody else. So anyway, that was a pretty useful one. And so there's different kinds of machine learning systems. Supervised learning is the easiest to understand, where you feed it data. For example, you're trying to pick spam out of email. So you take a bunch of labeled messages where a human has decided whether it's spam or not, and then you train your model on this thing so it can detect new emails and decide if they're spam or not. Unsupervised learning is the most common situation because if you just go on the internet and find a bunch of data of some kind, it's not labeled by anybody. You have a whole bunch of data, but there are no labels. So you can still cluster it, though. You can form it into groups. And this is appropriate if you have something like a recommendation engine at a shopping site. You have a bunch of customers. They've just done different things, and you just want to sort of sort them into groups. These people are buying like adventure books, so maybe we can offer them like, boots or something. These people are buying cooking books, so we can try to sell them fry pans or air fryers or something. You just sort of sort people into groups to try to figure out what you might recommend to them. Another thing you can do is find anomalies. you have like a production line and there's some normal distribution of product, and the ones that are outside the normal appear to be defective. So you just decide whether they're close enough to the average. And this is really important, and this is how the large language models work. You make supervised data out of unsupervised data. So you take data and then you mask part of it. Now you know what the right answer is. And this is how the image processors on cell phones work, where you can take a picture and then you can remove something you don't like from the picture and fill in the background. You train the model on this. You block out part of it, and then you make it learn how to fill it in, and you know what the right answer is because you artificially created a data set with a problem you could solve. This is very powerful. Large language models work this way. So what you do is you have a sentence here like artificial intelligence, you mask a word, take over the world, and the model has been trained on a whole bunch of sentences you found on the internet where you remove a word and have it guess what word should fill it in. So it learns what humans can do to deduce from context what this word probably is. And so after the model's been trained, it says to fill in that, can is the most likely at 32%, will at 18%, to at 6%. These are the possible completions of that sentence. And this is why, like I was saying yesterday, the large language models simulate intelligent human discourse. They make sentences where the words are in logical order and the words are the words you would expect to see in that sentence. So it reads like an intelligent human wrote it. Even though the AI has no idea what it's saying and doesn't know what the sentence means, it knows how to make that sentence look like a sentence you have seen before. All right, and all right, then the problem is securing AI systems, and there are several frameworks available for us. The U.S. government has given us the NIST AI risk management framework for AI. This, in my opinion, is authoritative, so I refer to it in my consulting with companies on AI, but it is a little hard to use because it's too high-minded. It's at too high of a level, and it's also believing a bunch of science fiction. I mean, the science fiction says the Terminator is going to have Skynet and kill us all, and unfortunately, the federal government researchers seem to actually think that's a risk, and that's mostly what they think about, which I'm unhappy about because it's not a real risk. Anyway, so harm to people, it might hurt your civil liberties and such. That's true. Hurt the community, hurt the society. There's some truth to that, even without AI. But more at a more low level, where a company would probably care about it, is probably harm to a business's operations. And then they have issues about hurting the natural resources and the planet and stuff. And maybe that's appropriate at the federal level. Most companies aren't really at that level. Anyway, this is a very useful chart to understand something about AI. The deep neural networks are what's ones the large language models, and they're an imitation of the human brain. They have layers of neurons. Thousands of neurons will all work together to process the data. And the problem is you cannot say what any one neuron does, just like you can't say it with the human brain. And so you can't implement a security barrier for a deep neural network because if it does something you don't like, you can't figure out which part of it to adjust to make it quit doing that because it's not really understandable. So there's interpretability against predictive power. They're the most powerful, but they're the hardest to control. There's easier machine learning models like linear regression, fitting a line through a bunch of points. That's very easy to understand how it works, but it's not very powerful. Decision trees are just a bunch of if-then statements. It's easy to understand how they work, but again, not very powerful. But if you combine hundreds of them together, you get random forests, which are more powerful, but a little harder to understand. K-nearest neighbors we talk about, which is a very powerful model, been around for a long time to classify things. And support vector machines are amazingly powerful considering all they do is draw a straight line and divide things into one side and the other. But it turns out in a high dimensional space, a straight line can be very powerful. And then there's these things called CANs, are the newest ones, which are almost as powerful as deep neural networks, but much easier to understand and control. And these have just been invented in the last year, and they may be a real candidate to improve your ability to control while still having high predictive power. And we'll talk about these in the projects. Next, the UK government also has a security model, which is much more at the level of a normal business. And here I found it quite helpful in the stages. So first, you're trying to decide what you're going to do. You define your objectives and have a risk assessment and issues of policy and compliance here. Then you develop your model. Then you verify and validate that your model is operating within acceptable parameters. And then while you're running it, you have to have good logs where you record what it does, you record what the complaints are and what the problems are, so you can measure, to what extent is it making trouble. That's the continuous validation down here with continual improvement. And then at the end, of course, you have to evaluate performance, figure out how to improve it, make sure you dispose of all the assets without leaking out data, and so on. So I thought this is actually quite useful for customers. It's too bad it's a UK standard. Then OWASP, the consortium of security groups, has got two top 10 lists for machine learning. This is general machine learning, input manipulation. I think I got these in more detail. The input manipulation is where this is evasion. This is the number one most common one, which is what we're going to have most of our projects in, where you have a model that has been trained to do something, and then you give it crafted input that the model will misunderstand and get wrong, exploiting its weakness. If you can modify the training data, you can teach your model bad habits. This happened to Microsoft about 8 years ago. They put an AI model in Twitter called Tay that would learn from the questions, and within a day, people had trained it to say horrible, racist, offensive things, and they had to take it down. They were learning from data that was teaching them bad habits. Then their model inversion and membership inference are ways for somebody to steal your model by deducing how it works, and model theft. Those are to protect proprietary models. Your software might have malware in the supply chain, like any other software, from bad libraries and such. And these other ones, you can affect the operation of the model. And then, of course, model poisoning, or you somehow, like data poisoning, you trick the model into being trained badly. So those are a little bit at the high level of generating a model. And probably the most important for most of us is the top 10 for large language models, specifically for the chatbots. The main one is prompt injection, the one you did yesterday. You can ask it a question that tricks the model into violating its security policy. If you trust the output could in fact include code like JavaScript if the output is going into a web page. If you can affect the training data, like I said, you can teach it bad habits. You can perhaps flood it and cause a denial of service. It can have bad software components coming in. And here's a big one. If you have a model and you train it on the questions from the users, which is how most of them work, then the problem is, this is what happened to the large language models in the New York Times. We'll see this in the hands-on projects. If you train your model correctly, it learns the trend of the population, but it doesn't fit the details of the training data. However, if you overtrain the model, it just memorizes the training data and repeats it back. And so when the large language models came out like ChatGPT, novel authors would go there and say, what happens if I give it, say, the first couple of paragraphs of Harry Potter? What do I get? And the answer is you get whole pages of Harry Potter exactly as written, which means the model has been overtrained. It has memorized the novels it was trained on and is just repeating them back verbatim. And so then the New York Times took them to court and said, you guys are committing copyright infringement. You're just memorizing our articles and then repeating them back. And the developers say, no, we're reading the articles the way a human would. We're learning the information in the articles, but we're not just memorizing them and repeating them back. And that's the question. Which of these is happening? But the end result is anything you give it for training data is likely to just be repeated back to future users. So if you train it on anything sensitive, that data is being compromised. So that's an important issue. Then you have something detailed with the plugins is not that important, but this is one that really bothers me, excessive agency, where you take an AI and you trust it to do something dangerous that it really shouldn't be trusted to do, like to drive a car. And then it plows into people. Like Teslas keep making the wrong move, plowing into, lately you find Teslas plowing to emergency vehicles a lot because the flashing lights confuse them. And that's the problem. You trust it to do something, and it's really not reliable enough to be given that trust. And the related one, which I think is the main one I'm always warning my clients about, is over-reliance. Humans believe what the model says when they really shouldn't. And we're going to see a lot of this, how these models lie. And they lie very convincingly because the only thing they know is how to make a good-looking page of printed paper. So even when they're totally wrong, it will look really good and convincing. And then, of course, model theft is if someone wants to steal your highly trained model. Not usually an issue because none of the companies I'm dealing with are making their own model because that's expensive. They're using the standard models. Anyway, And so Copilot is probably the most desired product, although there's a lot of products like it, and it's worth understanding how it works. This is Microsoft 365 Copilot. And um, so this will hopefully help you all over the world. You can ask it, summarize everything on this project I'm working this month and send an email, prepare an email for my boss describing like the 10 bullet points of what we should be doing right now. And it will try to do all that for you. And the way it works is this. You put it in the cloud, you connect it to all your cloud storage, your spreadsheets, your emails, your Word documents, everything you have. And when you ask it a question, it takes an old-fashioned search engine like just a keyword match, and it hunts through all your documents with this thing called Microsoft Graph, and it picks up all the context. So it picks up email messages, Word documents, spreadsheets of information, and then it adds it to the question. This is why I was surprised over the last year. The models have been bragging about how much input they can take. We can take 10,000 words. We can take 100,000 words. We can take 200,000 words. I say, well, why do you want it to take 200,000 words? I'm just writing a couple sentences for a question. This is why. My question is here, and then it adds all these pages of information it found to the question, and then it feeds it to a large language model like ChatGPT. And so it says, based on the attached documents, summarize this project. That's what it does. Now, if you use the free version, they will train it on your input data, which means that input data should be considered compromised. But if you pay, then they promise not to. They are using a cloud server, but depending on how much you trust Microsoft, Microsoft has promised they're not going to train on it and leak it out. Anyway, that's how it works. This is the fundamental product. And there are some obvious security concerns. One of the most obvious being, suppose I have an email that says, okay, don't tell your staff, but here's the people we're going to lay off next month. Now, Copilot probably doesn't know when I say summarize the prognosis for our business in the next year. It doesn't know, wait, that email was confidential. Don't include that in this memo I'm about to send to all the staff. In order to prevent that, you'd have to have sensitivity labels on all these. And to be fair, this is not really a problem with Copilot as much as it's a problem with the whole cloud. There's a great infographic down here talking about this problem. There you go. This is cloud computing. A typical multi-cloud environment has 40,000 permissions to manage. Most identities are greatly over-permissioned. Cloud identities outnumber human identities 10 to 1. Only 1% of permissions granted are actually used. More than 50% of cloud identities are super administrators with full access to everything because nobody can understand this and everybody's just giving full control over everything in the cloud. And that's the problem. In order to solve this, you would have to take all your reservoir of documents and label them as sensitivity labels, confidential, proprietary, top secret, or whatever you got. And nobody wants to do that. So the problem is it's combining all that information and it doesn't have any way to know which information it should be including in a document. Microsoft has a technology to label your output and carefully only use documents of that sensitivity, but it doesn't work because the stuff is not labeled in practice. So that's an issue. All right, and so here's the Microsoft 365 tenant, has 40 million permissions, 27,000 sharing links, 113,000 sensitive records shared publicly, and on it goes. So that's the fundamental problem with the cloud. All right. Anyway, this is the Microsoft technology. Microsoft Purview is the thing that will use sensitivity labels to control this, but it would only work if you labeled everything. Anyway, and so people have mentioned how to use it for cyber attackers because you can use prompt injection to trick Copilot into doing malicious things. And Meta's AI system has been defeated by simple tricks, like just adding some spaces in between the words so it doesn't hit their defenses. And home users face another world of madness. Microsoft has 2 or 3 times tried to roll out their Recall product. Recall takes a screenshot of your screen every 15 seconds and records everything you do on your computer and puts it in a database so Microsoft's AI can search through it for some unspecified benefit. A new feature in Windows 11. Microsoft tried to roll it out and the whole security community screamed, so they pulled it back, and now they've rolled it out to just beta testers. They really, really want to do this, and exactly why is unclear. The People that like Microsoft will say, well, they want to make a helpful agent that will read your emails and say, oh, you have an appointment coming up. And maybe that's true. The cynical people say Microsoft wants to steal all the data from everybody to train AIs on. But anyway, this is a pretty shocking invasion of your privacy, although Apple Intelligence, this coming on the new iPhone, sounds like it's intended to be the same thing. Although the early features of Apple Intelligence are really unimpressive, like filling in the gaps in photographs, that would do the same thing. It would read all the data on your phone and then somehow try to help you, like a butler or a secretarial assistant. Oh, you should know that you have conflicting appointments here or something. Maybe that would be helpful. I would certainly trust Apple to protect my privacy a whole lot more than Microsoft, but I'm not sure I want either of them stooping through my whole life and having AI trying to like tell me what to do. But maybe I would trust Apple to actually make it useful, but they haven't made it useful even in the Apple environment yet. They're all trying to do this though. In order for the AI to really help you, it has to know everything about you. And do you really want that? So far, people have not found this to be worth paying for, but maybe. Maybe Apple will make it a working product. Anyway, that's the background I wanted to show you, and we'll do a lot of these things in the hands-on. Let me stop this recording.